Well, thank you very much indeed. The power of the microphone has worked. We have a hushed audience, so it's my pleasure to be able to introduce our next speaker. We are delighted to be able to welcome Professor Simon Pearson, MBE, I must say, from the New Year's Honours List this year. And Simon and I go back a long way, fellow Lincolnshire Yellow Belly, but Simon is at the University of Lincoln, a founding director of the Lincoln Institute of Agri-Food Technology. He has much experience in agri-tech and is travelling the globe at the moment, representing the UK in various situations. Simon also previously worked at Winchester Growers and Marks and Spencer's, so has lots of relevant knowledge and information. So it's my pleasure to be able to introduce Simon to the stage to give a presentation all about agri-tech and sugar beet. Simon, over to you.
Yeah, what Mark didn't say, we used to go to school together and play tennis, and guess who used to win? And it wasn't me. So there you go. It's a long time ago. So thank you very, very much. So I'm going to give a bit of a quick overview. I'll call it Beet Tech, Opportunities of the Future. Some of it's about beet and some of it's not. What I really wanted to give you a view of sort of the direction of technology, where technology is moving, and hopefully it might inspire a few ideas for the future and about the way that we think about farming and some of the technologies that we're going to see. My group is at Rhizome and a very famous Lincolnshire campus. So we're about 30 odd people. We manage two what's called centres for doctoral training. That's PhD groups. About 110 PhDs across the United Kingdom in agri-robotics and agricultural AI. It's the single largest cohort of PhDs anywhere in the world focusing on those specialisms. And we share them with Cambridge, University of East Anglia, Queen's, Strathclyde and Aberdeen. So we're all over the UK. And then we do an awful lot of research translation. So I'm also founder of something called Ceres AgTech at Cambridge, and that is to create new companies. So we don't just do research for research's sake. We're very different, and we take ideas, we translate them, and we commercialise them. And we're trying to create as many companies as we possibly can. And the reason we want to create those companies is to fix them in our area so that we can, farmers in our areas can use those services, and then the people employed in those companies can live in our area, have great lives, and be part of society, and then grow the economy in Lincolnshire. So that's what we do. So why is agri-tech important? So we talk beet tech, and it's so critical. I come of it from a pretty diverse background. So I used to be managing director of Winchester Growers. I grew daffodils, 4 sites, 2 in Lincolnshire, 1 in Cornwall, and I grew flowers in Portugal as well. We employed 900 seasonal migrant workers picking flowers. That poor soul's in daffodils. It always makes me, you see people, tourists go down to Cornwall in the summer, it's all lovely and sunshine, then you go in the winter and oh God, it's pretty foul. And those people, when we was doing it, we were paying them 7 or 8p a bunch. I think they now got about 10p a bunch, but it's a pretty miserable job. And funny enough, people don't want to do that job anymore. So we need technologies to improve labour productivity and we needed skills as well. And, I look at these tractors around here and the skills to drive these things, I think are amazing. That's a very, very highly skilled job. And we need technologies to drive labour productivity. Then we need to think about society, food, the way people eat, making sure that we can keep supply of food for all. And then and then we've got climate change issues, and I'm going to come on to a little bit of data in a minute, which shows some of the massive challenges that we're facing in terms of climate variability, which is going on as a consequence of climate change. And then farmers have got to think about how they respond to that. I don't like the word resilience. I think farmers need to resist it, be resistant to it, and they need to figure out how to adapt to it. The reason I don't like resilience, it talks about staying the same forever, but actually farmers adapt. They keep changing, improving, moving forward, changing, improving. If you came to this conference 10 years ago, you wouldn't see a single bit of this technology here. Farmers adapt. They adapt. And this is the brilliant thing about farming. What is key in all of that is productivity. And what agri-tech's all about is driving productivity. And productivity, again, is a misuse of words. Productivity is about economic productivity. It's farms making profit, but it's environmental productivity. It's putting less inputs in, getting more out. And it's about social productivity, better jobs, better skills, better lifestyles and all that sort of stuff. Agri-tech is about all those three things. You can't have a good environment without profit, period. So you've got to do all of it. You can't do one of it. And that's what agri-tech is absolutely about. And that's what we're trying to do. I think it gets lost in the translation sometime about what it's about. So just a bit of data about sugar beet. Mark's got some more data in the next session. But what I've done here, I've just taken the one data set from this is UK yields, 1962, 2023, 24. And what you can see since 1960, and this is pretty similar for all arable crops. So we've seen a very big rise in yield, really from the 60s up to about 2010. Those yields, why are those yields increased? If you talk to a plant breeder, they will say it's plant breeding. If you talk to a Yarra or a fertilizer manufacturer, say it's fertilizers. If you talk to a pesticide company, Syngenta, they'll say it's pesticides. If you talk to John Deere, they'll say it's a John Deere. The reality is it's all four of them working together. And those four things working together created the farming system that we've got now, and that's driven yields. For sugar beet, I don't know what the yield potential is. It's what, is it 120? 180 to 200. So we're way off, aren't we? So the average there is 70. But then you look at the last few years, and nobody knows why that last few years it's got more variable. I suspect it's climate change, and we've got Andrew Mead here somewhere. He probably knows more about it, all the Rothamsted data that's going. You've got this huge amount of variability coming in, and some of it is about wet weather, some of it is about virus. In fact, 2020, I think, was the famously bad year. So you can see that dip, but you can see it's becoming more spiky, more problematic. I don't think that curve looks like it's flattened off. I think that's just because of the 2020 down thing, but you can see it's becoming very problematic, and we're starting to see the linear increase in yield that's happened since 1970 started to taper. So we need to think harder. We need to go further. If you look at total factor productivity, which really is the economic assessment of how British agriculture is doing, if you bear in mind that all arable crops, pretty much all arable crops, not entirely, but pretty much all arable crops have shown that yield spikiness and that sort of starting to level off bit, you would think the total factor productivity might have flattened. So total factor productivity is just simply the total outputs in cash divided by the inputs in cash. Total factor productivity, this includes animals, so it's slightly biased, but that's actually still increasing. So output, total factor productivity is still going up. So if prices are flatlining and yields are flatlining, input costs might be going down. It's a complex world, but there is still a slight increase in total factor productivity. So that's good news because it's not all about output. Some of the inputs are also very, very important. So why is AgTech an accelerator? Why am I really excited by AgTech? And really it's because I think it really embraces the whole of British science base or global science base for agriculture. This is the new thing. This is the new news. So basically agri-tech, in my definition, it's an industry engaged, it's an interdisciplinary science redefining agricultural science. So if you go back 5 years, all of the management and governance of British agricultural science was based on a bias towards bioscience, plant breeding and all that sort of stuff. and we lost our focus on engineering, technology, robotics, and we never had robotics, we never had AI. What agri-tech is, it's basically brings in, it enables us to bring in all these different science disciplines to respond to our problems. What we do is very simply, we work closely with farming communities, with farmers. We actually try and find really hard problems that have not been solved. And then we work with a very, very broad science community to then bring those solutions together. And then you work with the sector, the supply chain, civic society, policy to actually create these solutions. And just to give you an idea of the scale of what we do at Rhizome now, we've got projects with 50 different science disciplines working on agri problems. That's nuclear physicists, engineers, economics people, social scientists, that is plant scientists, that plant breeders, that is AI robotics people, the whole lot. So suddenly what agri-tech does, it opens up the whole of agriculture to the whole of British science. So if we can't actually make something move with that coming in, then it'll be a pretty sad day. And then it's a question of matching sector needs and technology opportunities, and why I've got a little bit of hope that we might move that yield gap a bit. I think it'll be you've got the noise from the weather, there's lots of new stuff coming. So we've got AI for decision support, a lot of AI going on. We have, I think now at Lincoln, we've now spun out 3 AI companies in agriculture in the last 2 years, and there's 6 more in train. A lot going on digital platforms, a lot going on genetics, robotics and AI. I'll come on to some of the opportunities in a minute. Machinery, I just think machinery is incredible. I was just looking at that drill over there. I just think it's absolutely outstanding bit of engineering. And there's a lot more of that going on. Autonomy, we're going to see a lot more autonomous tractors already in the US. Problems with regulations in the UK, which stifling that in agriculture a bit. Very excited by plant breeding, precision breeding out, as long as it didn't get binned with the SBS deal. I think we're in a good position with plant breeding. A lot going on in data, informatics, how do we improve? Crop protection moving on. New techniques, crop protection. I'm going to talk a little about robotics. I know in the weeding session you heard a bit about robotics. I'm going to show a bit about that. A lot of circularity, a lot of new fertilizers coming through. In theory, there's an awful lot of the phosphorus and P and K in the United Kingdom without the need to import a lot of fertilizers if we can get the circularity right. So that I think is going to come forward. Regens are moving at pace. Lots on greenhouse gas and biodiversity. So I see there's a huge amount of opportunity. I'm not frightened by the fact that there's no ideas out there. There's loads of ideas. What we need is really good people joining up as teams to solve those ideas, not people working in isolation on their own. You just got to have big teams doing it, and it's expensive work. So this is the sort of stuff that we do at Rhizome. That's the old hall, and that's where we work. So we've got about 30 people there. We do a lot on robotics. So this is a phenotyping robot going around wheat, and what we're doing, we're looking at new traits in wheat. We found a flag leaf variance, which you can't see by the eye. It's got a 5% yield gain opportunity around it. You can only do that with robotics. We do a lot on autonomous systems. So this is one of the robots. This is one of the companies we work with, Saga. They've now raised $40 million. They put UVC into strawberries. They've now got robots in 40% of UK fruit farms and across California. And then we do a lot on Beet. And this is one of the keynote things we have, which is one of the flux towers in one of our fields. Mark and the team came up 4 years ago, I think, had a look at that. There's now 2 or 3 of those now at Morley looking at greenhouse gas emissions in Beet. And I think there's some good news story. We haven't seen the data yet, but I'm hopeful that some good news story, and the sequestration of carbon from Beet is better than what most of the models say. I hope. We'll tell you fairly soon. This is some of the data. This is Beet. This is barley, stubble. This shows the carbon being sucked in by the crop, and this is the haulm respiring. But you can see sugar beet relative to barley, it's doing really good. There's a lot of carbon going into that field, and you'd expect it because it's a sugar based crop. Then we've got lots of PhD students. I don't know if where is he? Put your hand up. Over here, funded by BBRO. That's looking at root cycling. We do a lot on robotics. This robot is one that we've worked with. This is a soil sampling robot, so it just wanders around and puts a core down. You can do a core, it can take your soil sample out, it will intelligently work to sample, and then this one, it's just measuring greenhouse gas emissions from that particular piece of land. The really clever thing is it works out where to do the mapping, so you can just give it a blank sheet of paper and it will do the whole field intelligently and autonomously. And this just shows over that field where the flux is coming from. So you can see there's an awful lot of variance within a field on carbon distribution. We've done a lot on robotics. This is eco-robotics. I helped some of the investors with eco-robotics. This is in lettuce, but it's being used actively in sugar beet. It was designed really. The biggest thing is for sugar beet. It's an AI-enabled weeder. So AI takes an image of the weeds, and then the nozzle then sprays. You see it spot spraying this in carrots, and it's spot spraying away. It's a really, really good bit of kit. There are other ones around there, so I don't want to do an advert for eco-robotics, but this is the one that's moving. These are the cameras inside. They're very accurate. The actual engineering's really bloody clever in the way that it actually tracks the weed and puts the nozzle in. This company's now raised, I think, $200-300 million. It's almost the same as the cost of launching a new herbicide from eco-robotics. So I think it's pretty good. Beet is one of the primary areas. So that's AI, robot weeding. We'll see a lot more of that. All plant breeders now are using lots of AI. They probably don't even know it, but they are. And so this is one where you've got the robot moving the beet to a camera thing, and there's your cameras. Take an image of the canopy. You then use AI to reconstruct canopy, and you can identify the traits very, very quickly. So most of the new varieties I would think that are bred now are AI influenced because of the imaging technology to do the breeding. Another one of our PhD students who's done aphid counting, and this is a really clever bit of work where you can count the aphids in the trap using AI. And then he even did this thing where he put one of these bloody dogs in a beet field, and it wandered around. It found a trap. Here you go. This is spot the robot dog, and then it looks in the trap, and here you go. And in theory, you can see what it's looking at here, and it opens its little jaws, and then it can look in the trap. Here we go. And there you do. Then it'll get your image there, and it can do your count there. So, is that going to any agronomists here? No, yeah, your job's safe. Don't worry. You will not be replaced by one of these because the battery life is only 40 minutes. So you are perfectly safe. Yeah, exactly. But and we also when we did this just to do. I just really enjoy this video. It's again some of the PhD students we were herding sheep with it, and again the sheep are actually very safe because again it's only got a battery life for 40 minutes. So I think the sheepdog's probably going to be looking fairly smug, but I just love the way that the sheep are looking. Look at that one. Going, what the hell is that bloody thing? And here you go, and they're all going, oh Christ, what is that? It must be like being on a Doctor Who set, mustn't it? If you're a sheep. And here you go. I just think it looks really mean. So we're going to see some of these vehicles. I don't know if they're particularly practical. I mean, I think actually for sugar beet, it'd be quite good for bush beet. If you've got pheasants in there, I reckon that it would scare a pheasant off quite a mile away. So that's what we do. So it's the sort of stuff we do, but it just wants to give a flavour that there's a lot of newness and novelty out there. And it's not, and I'm afraid the problem with all these technologies is they are expensive and it takes time to get them out there. And it's very frustrating when you see these things coming along and they never seem to appear. But it does mean persistence and long-term gain. Sort of stuff BBRO are absolutely fantastic at. I just want to fly a flag, my final flag for UK agri-tech. I do think we are world leading and thought leading. And this is a report that George Freeman, who's a Norfolk MP, came to Rhizome last week, and the week before last, has published about what we should be thinking about for the future of innovation in agriculture. and he's got this 30-50-50 vision, which is 30% increase in production. And I think Beet, we can do it. If you've got a yield gap of that amount, there's plenty to go at, but 50% reduction in impact. George wants to do it by 2050, so 30-50-50. So if anybody wants a good read, get into detail, I do recommend this. But we do have thought leadership, and we are leading the way in agri-tech. We just need to go faster and get that technology in your hands. So that's it. So thank you very much.
Thank you, Simon. Fascinating insight to technology and its value within the agtech sector, and particularly sugar beet. I'm sure the BBRO team, and me particularly, having spent nearly 40 years counting aphids, to have a system that would do it for us would revolutionise and simplify that particular task that we've done for many years. I'll also just add to the fact that I think the world record potential for a commercial sugar beet crop was grown either in California or Chile, and it's around about 220 adjusted tons. So it just shows what potential is out there if everything stacks in your favour. So that's something just to work towards and aspire. Sometimes we see within recommended list trials some of these yield potentials up to 150, 160 adjusted in the small plots that we work on, but it just demonstrates what is potentially possible under UK conditions.